So, as you know, this is Dr. Nandi. Today, we are going to talk about experimental studies in statistics. Remember, so far we have talked about what is statistics all about. It's collecting information through surveys, analyzing the information, then drawing some conclusion. Okay, and one of the main goals of our study is to see how we can uh, draw an inference on population characteristics. So sometimes we conduct experimental studies, we conduct experiments to find out the effect of certain variables. Variables we also touched bases before. Variable is a factor that can change from one value to another value. Variable, as the name implies, is a condition that varies from subject to subject. Hence the name is variable. Before I go any further, please subscribe to my channel by hitting the red subscribe button. I lecture often on statistics. I also have recorded videos on statistics and have solved problems using calculators in statistics. I have also solved algebra and calculus problems in my channel. So please subscribe to my channel by hitting the red subscribe button. So without further ado, let's get started. As I was saying, today we are going to discuss experimental studies as they are used in statistics. Okay, so what is an experiment in statistics as applied? Experiment is where we want to study the effect of one or more variables more precisely, one or more explanatory variable, and I'll just explain in a minute what I mean by explanatory variable. Explanatory, the name comes from explain. Explanatory variable on a response variable. Okay, so explanatory variable is a factor that explains the results, the response variable. Explanatory variable, the word comes from explain. Okay, so an example of this, EG stands for example. Does room temperature make a difference in test scores in a stat class? Okay, so what we can do, we can conduct the same test on two sections of the same of stat class of stat at the same time on a summer day. Only difference on a summer day. Okay, one room is maintained at say 67F, and the other room let's make it interesting. Let's make it 65F, and the other room is maintained at 70F. Here you clearly see, will be able to see the effect of temperature. Same test conducted in same stat classes, two different sections, one and the same time of the day, 10 a.m. in the morning, say, okay, same time, this is important, same time, okay. One of the room is kept at 65°F, this is a hot summer day, and the other room is at 70F. Here we will clearly see, does temperature, which is the explanatory variable, have an effect on test score, which is a response variable. Okay. So here you saw explanatory variable. What is its effects on the response variable? Another type of variable may be extraneous variable. Extraneous variable. Okay. A variable that is not one of the explanatory variables. A variable that is not one of the explanatory variables. Remember in the previous experiment, temperature was the experimental variable, explanatory variable, okay, but is thought to have, comma, so extraneous variable is a variable that is not one of the explanatory variable. In our case it was temperature, but is thought to have an effect on the response variable. On the response variable. What is an example of that? Okay. Example. EG stands for example, like I told you before. Okay. Time of the day. Can affect test scores. What do I mean? Okay. Conduct the same test on in two different sections. Sections of stats. Okay. With both rooms at the same temperature. Same temperature. 70°F, say 70F, but one at 8 a.m. in the morning, 8 a.m., and the other at 2 p.m. At 2 p.m. Okay. It is observed that students are more alert in the afternoon than in the morning. So test scores for the section at 2 p.m. will be higher. So time of the day. Time of the day is the extraneous variable. Time of the day in this case is the extraneous variable. Extraneous variable. Okay. Now, effect of some extraneous variables can be controlled by blocking. Effects of some extraneous variables can be controlled by blocking. Here block means groups, different groups, grouping. How so? Okay. Think of a new method of teaching. Method of teaching reading skills for grade 1 through grade 4 students adopted in a school, adopted at a school. Okay. After 6 months of teaching with the new method, a test is conducted. Okay, so let's go on the other side and continue with this thought process. Okay, so remember, I'm testing the effectiveness of the new method. Randomly select students to form a test group. Okay. You find that after 6 months of teaching, reading, teaching to improve reading skills with the new method, using a new method. The scores are higher. But here there may be a problem. Higher. What may be the problem? Okay. If there are too many fourth graders in the test group, then we know that fourth graders already have a higher reading skill, already have a higher reading skills than first graders. So we will not be able to test clearly the effectiveness of the new method. This is because we have put too many fourth graders by random chance in our test group. Fourth graders already have higher reading skills, plus they're being taught with a new method, so the scores will be higher. So we do not know whether their scores are higher because they're fourth graders or because they're taught with a newer method. We will not be able to test the effectiveness of the new method. So in this case, what is the best option? Divide the students into blocks. What are the blocks here? Blocks are the grades, or separate grades. So we have grade 1, 2, 3 and 4 separated. Then we will test. So the blocks are the separate grades. Okay. Then we will test the effectiveness of the new method in each block. Effectiveness of the new method of teaching separately in each block. That will give us a true picture whether the new method has significantly improved the reading skill in each block. Because we are not mixing up the fourth grade with first graders. First grade is separate, second grade is separate, third grade is separate, fourth grade is separate. And we are doing testing from randomly selecting students and performing the test in each grade or each block. Okay. So these are called blocks in this case. Okay. What is an extraneous variable? Extraneous variable. A variable that is not one of the explanatory variables. Explanatory variables. In the study. But is thought to have an effect on the response variable. What is an example of that? We already talked about it. Okay. Time of the day. Example. Time of the day is an extraneous variable. When the test is conducted, is an extra in a classroom. Is considered to be an extraneous variable. Considered as an extraneous variable. We already talked about students are more alert in the morning. Okay. So instead of conducting the test at 8 a.m. in the morning and 2 p.m. in the afternoon, what we should do is probably conduct the same test. On two different sections of stats. In two different rooms. In two different classrooms. Maintained at 70 degree Fahrenheit, maintained at 70 F at say 10 a.m. Then the effect of the extraneous variable, okay, the effect of the time, morning and afternoon, that is removed because the test is conducted on two sections, same test on two sections of stats. Room temperature is same in both the rooms and the test is being conducted at the same time. So effect of the extraneous variables is removed. Okay. 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 Now let's talk about, we should select samples randomly without any preference, and the selected subjects should be placed randomly in two or more experimental groups mental groups. What is an example of that? Okay. Okay. Test a new drug to cure a tough disease. Okay. What do? We recruit volunteers randomly. They are randomly assigned to two groups, randomly assigned to two groups, two different groups. What are these two different groups? One is called control group. Control group. What is a control group? These people get a placebo. Placebo. So let me write it correctly. Maybe I should also change the color of the ink. Placebo. You may have heard the term before. Placebo is sugar pill. Sugar pill. It looks exactly like the actual medicine, same color, same texture, same taste, but does not contain the medicine. It contains sugar only. The other is the test group. That gives the actual pill. So we are recruiting participants in the study. They are selected randomly. Not only the participants are selected randomly, they are also placed randomly in the two groups. One is the control group, which gets the placebo sugar pill, and the other gets the real pill. That is the test group. Why do we keep a placebo or the control group? Because then we can compare apples to apples. We will see whether the placebo group or whether the test group, which gets the actual pill, is really more effective in curing the disease which we are shooting to cure. Okay? And the control group, which gets the placebo, should not be as effective in controlling the test group. Okay? Okay, so I think we have covered almost everything. Okay, here we talked about the extraneous variable, which is the time of the day, and the other is the we control it by having the two rooms at the same temperature. Okay, same temperature. This is important. Otherwise, this will confound or confuse the results. Okay, this is a confounding variable, temperature. Keep the room temperature in both the rooms same. Okay. Now we are looking for extraneous variable. What is the effect of extraneous variable? That could be time of the day, morning and afternoon. We don't want to remove the effect of extraneous variables, outside variables. How do we do that? Conduct the test at the same time of the day. Okay, maybe at 10 a.m. Okay, then we will remove. Do not do the test one at 8 a.m. in the morning, another at 2 p.m. because then time of the day will have an effect because it's an extraneous variable. Okay, and we should select samples randomly. Okay, and place the selected sample randomly in the two different groups without any preference. Why do we do all this randomization? We do randomization because we want to find the real results without being complicated by extraneous variables or confounding variables. We want to keep everything clean and clear. That's why we take care of controlling the extraneous variable and the confounding variable, and we randomly select samples from the people who want to participate, then place them randomly in the two different experimental condition groups. Okay, so there is no bias in selection, bias in placement. Again, hopefully in this way the results we get really shows the effectiveness of a new drug if you are testing in this case. So I stop here today. If you have any question, comment, do not hesitate. Please do not hesitate to write me a comment. write me a note. If you like this video, please give me a thumbs up. I really appreciate that. And if you like this video, share with your friends. And please subscribe to my channel by hitting the red subscribe button. And please do not forget to click on the bell button, which is you will be notified every time I upload a new video, which is quite often. So please subscribe to my channel, let my channel grow. I appreciate that, and I appreciate the fact that you took time out of your busy life to listen to my presentation. And I hope to see you tomorrow. Thanks for watching. Take care. Have a nice day.